So anyways, the Pythagoreans had this beautiful representation of the world with geometry, and they had their famous Pythagorean theorem, which is represented right here. And don't worry if you don't quite understand this, we're going to talk more about it later. But essentially, it says that if you take a side times itself, and then you take the other small side and multiply it by itself, when you add those two together, you'll end up with the exact size here times itself. Well, Hippasus is credited with recognizing that if the two sides are the same length, for example, then you end up with c times c equals 2. And if c times c equals 2, when you take the square root of that, you end up with a number that goes on forever. Which means this side has a length that goes on forever. That just completely shattered the world of the Pythagoreans. They did not seem to like this idea, and that's the way it is with a lot of new math ideas that came in, just like zero, when zero was first introduced. And so they thought this was math heresy. And so they invited Hippasus, as the story goes, out for a little sailing boat trip. And they went out into the Mediterranean, and when they came back, Hippasus was gone, and later it was determined he drowned. But that still doesn't end this idea, and we now recognize these as an actual number. The square root of 2 is an actual number, and we call this number an irrational number, because it's not a rational number, it's an irrational number. And there are other places where this sort of thing crops up. If you take a circle and you divide it by its radius, you can get it divides a certain number of times, but then there's a portion left over that again goes on for infinity. Well, this is all proportional to what we call pi, and we'll talk about that again later. Well, these are irrational numbers. So now we can throw these numbers in the mix too. So now if we look at our counting number line, we have positive negative numbers, positive negative fractions, positive negative decimals, integers, whole numbers, natural numbers. This whole set is represented on this line, and now we have the new addition of numbers called the irrational numbers. So this is square root of 2. It actually represents a number. The best way to represent it is with this symbol, square root of 2. Otherwise, we would have to estimate it with a decimal. We have a number here that a lot of us know, 3.141, but really we often just represent this by a symbol also. Pi, it's another irrational number. So here we go. We got our natural numbers, our whole numbers, our integers, our rational numbers, and our irrational numbers. And this whole set of numbers is what we play around with, especially in science and engineering. And we call this our real number set. So these are all the numbers we use in these number lines, and we call them the real number set. So let's talk about operations on real numbers. Now before we start, let's define exponents. It's just a way of writing a certain type of multiplication. So if I were to take a number represented generally by A, and well, actually let me start out with an actual number. If I were to take a number like 2 and take that same number and multiply it together, 2 times 2 is 4, times 2 is 8, times 2 is 16. This equals 16. I can represent this instead of this laborious long, and it could be really long. Maybe what if I were to do this 100 times? I wouldn't want to write it. I could represent this with something we call an exponent, where this is represented by 2, and up here as a superscript, I write 4 because there's 4 multiplications of 2. Now, if this were written as a variable, so any number I can stick in there, any real number I could stick in there, I could raise to a real number exponent. In this case, it would be a to the 4. B would be equal to 4. I'll keep it there. So now that we've introduced exponents, we can talk about order of operations. It's necessary for us to define and order operations because we have to be able to read our symbols that we write. For example, if I write this equation 24 minus in parentheses 3 plus 2 times 3 minus in parentheses 2 plus 1 squared, what does this equal? What do we do first? What do we do second? So on and so forth. That's what order of operations is. And well, here is our order of operations from top to bottom. The first thing you want to handle are anything in parentheses. Then perform exponent operations. Then multiplication and division, and then addition and subtraction. So that's the way we have decided we are going to follow our math script. So in this example up above, the parentheses first would be, so 24 minus, do the parentheses first. So in parentheses, we have 3 plus 2 here, so this is going to be 5. So that's the first thing we're going to do. This will be 3. Okay, step 2, we're going to do the exponents. So now we have 24 minus 5 times 3. We're just going to hold off here. 3 squared, 3 times 3 is 9. Step 3 is multiplication. That means 5 times 3 is 18. Nope, 5 times 3 is 15. And then finally, we can handle addition and subtraction. So 24 minus 15 equals 9 minus 9 is 0. And that's our final answer. So this is important for you when you're working things on a calculator and you're quickly working on a test. Make sure you're typing in your work and performing things according to order of operations. Now you can go and grab an online calculator, maybe with your cell phone. This is the calculator for Windows 10. Now Windows 10 has a problem. The standard calculator, there's an error in its programming. It does not follow order of operations. If you switch it over to scientific, it does. So let's see. 24 minus 3 plus 2 times 3 minus 2 plus 1 raised to the power squared. Let's see what we get here for an answer. And we get the same answer. So the scientific calculator follows order of operations. But if you go and you look at your standard calculator does not follow order of operations. I'm not going to type in this whole thing again. I'm just going to demonstrate. 1 plus 2 times 3. 1 plus 2 times 3, if we followed order of operations, we do the multiplication first, which 2 times 3 is 6, plus 1 is 7. 7 should be the answer, but look at the answer this gives. It gives 9. It doesn't follow order of operations. It arbitrarily does the operation from left to right. This is incorrect. It's amazing that Microsoft has not fixed this. But anyways, Go to Scientific Calculator if you're going to use the calculator in Windows. All right, now let's talk about properties of real numbers. Properties of real numbers are ideas that we have decided we want our numbers to follow. And so properties of real numbers are set up to solve that issue. For example, Brahmagupta, he laid out the properties of 0, so it would fit in with the number rules when he did that back in the early part of the first millennia. So our first one is commutative property of addition. And this simply just states that A plus B equals B plus A. I'm not going to go into detail here. You can play around with that one on your own. But essentially, with addition, order of operations doesn't matter. Same deal with multiplication. A times B equals B times A. And next is associative property. A plus B plus C equals A plus B plus C. That's the addition. Multiplication side is A times B times C equals A times B times C. So you can reverse the order where you take your multiplication or your addition, the associative property. Next property is a little more important to us, the distributive property. The distributive property says that if you take a single value and you multiply it by the sum of two numbers, you could take individually and multiply by each individual number and have the sum of the two additions, the sum of the two multiplications separately. So let's do an example of this one. So here I have 3 times 2 plus 1. Well, this should be equal, according to this rule, to 3 times 2 plus 3 times 1. Well, 3 times 2 plus 1, order of operations says we have to do this first. So it's 2 plus 1 is 3. So 3 times 3 is 9. So this equals 9 over here. Okay, over here we have 3 times 2 is 6, plus 3 times 1 is 3. That equals 9. So yeah, it works. Okay, finally, let's just mention the identity properties. These are a little intuitive. If you take a number and you add 0 to it, you get the number, the original number. If you take a number, you multiply 1 by it, again, you get the original number. Those are called identity properties. And the purpose for learning all this stuff is so we can solve and simplify expressions. For example, 4 plus 6 minus 10 divided by 2. Well, order of operations states we have to do multiplication and division first. So 10 divided by 2 is 5. And then we can put in the rest, 4 plus 6 minus. So now I can do these in any order, associative property. So 6 minus 5 is 1, plus 4 is 5. So the answer to this is 5. Say we want to simplify an expression with a variable in it. Well, 2y minus, again, order of operations. We have to do this because it's the exponent. So in the parentheses, actually, we're going to do the parentheses first. 4 squared y minus 11 equals 2y minus 16y minus 11. So now we're down to just addition. So these are like terms. So 2 minus 16 is minus 14y minus 11. And that's where we're going to stop here.